let's get started. Today, I'm going to have a go at creating some electricity. The things I've got here on the table is what I'm going to use. These and what's in this bowl, which I'm going to explain in a minute. First question, actually I'm going to explain now what they are. I'm going to say I've got this little disc here. Does anybody know what this is made of?
Metal.
Metal, yes. Does anybody want to have a guess at what type of metal it is?
Steel.
Close? Maybe? Any other guesses? Silver in colour.
Silver.
But it's not made of silver.
Zinc.
Yes, this is a zinc washer. Alright, and the other thing I've got here is some 1 and 2 cent coins.
What are they?
These are coins that we used to use in Australia.
What?
We don't use them anymore. Does anyone know what they are made of?
Coin.
Metal.
Metal? Yes, they are made of a kind of metal. Anybody know what it is? It's reddish in colour.
That's not red.
Rididium.
Okay, these are made mostly of copper.
Red cream.
So we've got some copper and some zinc metals. In this bowl here, I have some lemon juice and some seeds and some little bits of paper towel here, which have been soaked in lemon juice. And this little LED here is the light, which I'll be attempting to power with my electricity. Who thinks I can power this little light with these metals and this lemon juice?
I don't know.
I do.
You do? Alright. Just to make sure this is working, and to give you a bit of an example, I've got some batteries here. So we know that these have the potential to create electricity, and in your torch they'll sit like this, for example, and they'll be able to power the little bulb that sits at the top. So I'm going to use this piece of wire here, which is what happens in your torch at home. When you turn it on, you connect up the bottom of the battery with the top of the other battery, and if I can get it to sit in the right spot, and then I'll get this light here and connect it to that part there and this one, and it lights up just like that. So when I connect the bottom of the battery to the top of the battery via that wire and the light, it lights up. So we know that this is working, and if I can create some electricity, it should light up just like that. So creating something like a battery with this is what a man called Alessandro Volta did in 1800. He created a thing called a Voltaic pile, which is the first kind of battery. Voltaic pile, sorry. Which is the first kind of battery ever invented. And to start it...
What about the Baghdad battery?
No, Simon, there wasn't a battery.
There is yeah, go with that. Wasn't a battery.
That was a cell. Alright, fair enough.
Also, it wasn't a cell. It wasn't used as a cell.
Ah,
okay.
You don't know that.
Focusing on the discussion here, guys. On the demonstration. So I'm going to start by putting this piece of wire down, so that when I build my little pile, I'm going to be able to connect the top of it to the bottom of it. Now, I'm going to start with this piece of copper by putting it on the bottom. And then I'm going to get a little piece of this paper towel here, soaked in lemon juice. So we don't want too much lemon juice. And I'm going to sit it on top of the copper like that. And then I'm going to get one of these zinc washers and put it onto the top there. Alright, so what I've got there is one cell, and that should be producing a small amount of electricity. So we will have a go at using this multimeter to see if it is creating some electricity. So if I touch one on this piece of the wire and one on the top, actually I'll put it around the other way, one on there, and we can see that we've got about 0.9 of a volt there with just one piece of copper, one little piece of paper with lemon juice, and one little ring of zinc. We have created almost 1 volt of electricity.
How does that compare to the battery?
These batteries that I had here were 1.5 volts.
Wow.
So in just that, we've created almost as much electric potential as occurs in here.
But that's smaller. Why are the batteries so big? If you can produce 1 volt just from that.
This is pretty awesome then, isn't it?
Yeah.
We should make all batteries like this.
The battery will last longer.
Yes, that is a very good observation, Simon. The battery will last longer. But this is cheaper.
How long will this last?
I don't know.
This will last for a few hours, I believe. But we're not testing that today, so maybe you can test that when you go home.
Okay.
Alright, so I'm going to put on another cell now. So we start with the copper. And put another piece of paper towel on top.
Why do we need the paper towel?
Alright, I can explain that now if you would like.
I would like.
Okay. The paper towel acts as what we call an electrolyte. And it contains ions.
Like Powerade.
Yes, it contains ions like Powerade. In Powerade, they're good for your body. Here, they're part of a chemical reaction which occurs between the two pieces of metal. So what's happening is the copper is interacting with the lemon juice there, and it's creating a chemical reaction which is producing free electrons. Now, electricity is the flow of electrons. So,
Whoa.
yes, exciting stuff. So the flow and the zinc is also interacting with the lemon juice. If I lift this up, you can probably see how it's starting to go black there. That's a result of the chemical reaction which is occurring. Some evidence there of our chemical reaction.
What is it?
That's what happens when the copper reacts.
What is
When
it?
the zinc reacts, sorry. It's zinc oxidation.
Zinc oxide.
Zinc oxide, yes. Alright, so yeah, it's creating free electrons, and because one metal will react stronger than the others, one metal will react stronger than the other, and that will become positively charged, and that in this case is the copper. So the copper is becoming positively charged, and the zinc is becoming negatively charged.
What makes the copper stronger?
That's a property of the metal, I believe. Yep. And the difference between the two metals, one being positively charged, one being negatively charged, causes the electrons to move from one to the other, creating that flow of electrons, which creates the electricity. So when we connect it top to bottom, it creates the circuit, and that will create our electricity from the electrons flowing through the metals and the electrolyte, which is the lemon juice, flowing around and creating the electricity. Alright, so now we've got 2 cells on there, and we'll give it a measure. So now we've got, it's jumping around a fair bit, but we've got up to 1.8 there. Good. So with 2 cells, we've got 1.8 volts. So we've already got more than in this battery there, which is pretty cool. What we might have a go at now is our little light. Alright, so there's a certain way it has to go around. Doesn't look like we're getting anything at the moment. But we'll add on another cell and see how we go. Does anyone think this is we're going to be able to make the little light turn on?
I think
You're
so.
doubting me. Think
Copper
we
cells.
will?
Need
Couple
more
cells.
cells.
We need more power.
Alright, and another zinc. Alright, and we got another cell. So we'll measure it.
Above it.
2.7 over there. 2.7 now, so we've added another volt with another cell.
Another 0.9.
Almost another volt. Alright, have a go with this light. Oh, look at that. That worked for a minute. That file's falling over a bit. Nope. We've got to make sure that the wire at the bottom is connected to the metal.
Put it on loop.
Yeah.
Ah,
Wow.
there you go.
No, yeah.
There you go. So we got a little bit of a faint glow there.
Take it off and put it on again. Oh yeah.
Yep.
Wow.
Turns on when I connect it.
Capacitor.
Like that. We made a battery. So that's pretty cool. So with just 3 little cells there, 3 copper discs and 3 zinc discs, we've been able to turn on this light. Just a recap of how that worked was we've got the lemon juice between the 2 metals there, creating a chemical reaction, reacts more strongly with one metal than the other, and that chemical reaction creates a flow of electrons, and yeah, the difference in the reactions causes it to flow through the metals and creates an electrical circuit, powering this little light. Okay, so here, to save some time, I've just made a pile of 13 cells here, and we're going to just see how much power we've got. 11, almost 12 volts there, 11.7 volts. And the 12 volt LED will have a go at powering this one. And there we go. Look at that, lighting up. It's pretty cool.
I'm gonna put it in